Welcome to Offshore Pipelaying. Let's start at the beginning. What is pipelay and how it is done from a surveyor's point of view? Pipes are laid offshore to connect various offshore platforms. These pipes carry crude oil and gas from the drilling platform to the processing platform on the field, and from the processing platform to the nearby shore facility for further processing. These pipelines are the lifelines of offshore oil and gas field. Majority of these pipelines are 12-meter section of steel. Some are also flexible. So we normally categorize these pipelines into two major broad categories: rigid pipelay and flexible pipelay. A surveyor's main job is to help the client position the pipelay barge on the main intended route and help the client with information like distance to go, any underwater obstructions or crossings of any other pipelines. So first thing first, as a surveyor you must have the approved for construction pipeline details and a bathymetric chart showing everything that is underwater, all the sonar contacts, depth of the pipelay route and any other significant information, and you need to plot everything, the route as well as all the sonar contacts and pipeline crossings, into your navigational computer. As soon as you are on board the pipelay barge, you need to measure its shape and the various offsets. The most important offsets of a pipelay vessel is the beach stall and the stinger hinge, and we'll talk about it later in the video. In this video, we'll talk about shallow water pipelay in S-lay method. S-lay method is most suitable for laying pipelines in the water depths of 100 meter or less. As you all know that my YouTube channel is a free educational channel, but in our society we do not value something which is free. To show that you value the free education, please click on the join button, and with just 29 rupees or 35 cents a month, you can be a member of this channel. If you do not want to commit to a membership but want to show your appreciation for any videos you want, then you can click on this thanks button and buy me a coffee. You will have preferences in my reply to your query. Let's get back to pipelay. All pipelay barges will have a dedicated laying corridor inside the barge. This corridor is called the firing line. There are many stations along the firing line where 12-meter segments of pipes are welded, x-rayed, repaired, wrapping and foam filling section. Every station plays a crucial role in joining the pipe segments, but for surveyors, station 1 or the beach stall is the most important, and you need to have an offset point for beach stall. There will also be a minimum 2 tensioner which controls the speed of the pipe coming out of the barge and also acts as an emergency brake to stop the pipe from running out of the back. At the end of the barge there will be a long structure with rollers which helps the pipe maintain a safe profile as it enters the water. This structure can have multiple segments and it can be lowered or hoisted to maintain the pipeline profile. This segment is called stinger. The stinger joins with the barge stern in a set of hinges, and as a surveyor you need to measure the offset of this joining point. Now let us look at the complete process of what happens when a barge comes for laying pipe. First, the barge comes and sets up at the starting location, and 7 or 8 joints are already welded and kept in the firing line. First, the barge have to decide on the pipeline initiation process. The barge needs a holdback point onto which to secure the pipeline head and start moving ahead. This holdback points helps maintain a particular tension on the pipe so that when the barge crawls on its anchor, the pipeline will stay there and comes out of the stinger end. Three different types of holdback points can be used for pipelay initiation. First is a jacket startup. In this, a cable is attached to the platform leg, which is then connected to the startup head or the pulling head of the pipeline. Keeping the tension on the cable, the barge pulls ahead, and after about 30-35 joints, the pipeline touches the seabed and normal pipelay operation commences. Some field operators do not allow this process as this can create vibrations on the platform due to tension in the cable. Another popular method is a bowstring method. In this method, the entire platform leg is assumed as a bow and a cable is attached loosely on the top and bottom of the platform leg. The pipeline pulling head cable is attached to this bowstring with a shackle that can move up and down the bowstring cable. As the pipelay progresses, the rolling shackle rolls down the bowstring. This method is better in the sense that the excessive pipeline sagging is avoided. Touchdown of the pipeline is achieved earlier and vibrations in the platform is minimized. Third method is by deadman anchor method. This is used when there is no platform present at the initiation of the pipeline or the platform operator does not allow for connecting cable to the platform leg. In DMA method, you need to drop a huge amount of weight and anchor far away from the actual startup point, and that must be perfectly in line with the pipeline route. The distance depends on the water depth. You then attach a startup cable to the DMA and at one end at the pipeline startup or pulling head. Barge will slowly move ahead, taking the slack on the startup cable and then under tension starts pulling the pipe normally. This is the best method as there is no hanging pipeline and the pull head is lying on the seabed. 12-meter segment of pipes are supplied to the lay barge by pipe barges. Pipes are first transferred to the lay barge. Once the pipes are on the rack, initial cleaning of the steel surface is done, and after that the pipes are beveled at both ends for better welding. After this, the pipes are transferred to the ready rack. At the ready rack, the pipes are preheated at both ends. This station is also sometimes called station 0. Pipes are numbered sequentially at this station. After the preheating, the pipes then go to station 1 or bead stall. In the bead stall or the first welding station, they will align the new pipe with the long section of pipe that has already been joined previously. After the proper alignment, welding between the joints is carried out. In some big barges, there are also another welding station where they join two pipes together. This is also known as double joint. Once the first set of welding is done, the bead stall gives a signal that the pipe is ready to move. This signals the anchor operators where a button lights up indicating that station 1 is ready. Similarly, when all other stations are ready and all the signal lights are green at the control tower, the anchor operator will blow a loud horn indicating to all personnel that the barge is now moving and start pulling on forward anchors and pay out the stern anchors for the barge to move ahead. The tension is slowly decreased from the tensioner and the barge moves ahead, leaving the pipe behind. On completion of the movement, the anchor operator will blow the horn twice in quick succession, indicating that the barge movement is now completed. There are multiple stations along the firing line corridor. Multiple stations for welding, X-ray and repair if required. The penultimate station is the wrapping station. Here they heat up the raw steel segment of the pipe and then wrap it around with a heat shrink material which also prevents water from direct contact with the steel pipe. Next, the joint moves to the last station. Here they wrap the entire length of the exposed pipe with some kind of metal sheet and tie it up at both ends, and then pump a chemical mixture inside the wrapping. This mixture creates foam that completely covers the joint segment. So when the barge moves ahead, it moves by 12 meter only at one time. In case of a 24 meter or double joint in the bigger barges, the barge moves by 24 meter at one pull. In double joint barges, the stations are more to accommodate two sections of joints at a single time. So what is our job as a surveyor? As soon as the barge movement is completed and a new segment of pipe is being aligned at the bead stall before welding, you take a position fix. In this position fix, following data will be logged. That is your bead stall position, your stinger hinge position, stinger tip position, and most importantly, the theoretical touchdown position. Now, what is touchdown? This is the position where the pipeline that is coming out of the barge is touching down on the ground for the very first time. The distance between the barge stern and the touchdown point horizontal distance is very important as it defines the correct S profile of the rigid pipeline. If this S profile is not maintained properly, then the pipeline might buckle under its own weight. Now this touchdown distance depends on the water depth, and the field engineer must give the surveyor a list of the touchdown distances depending on the water depth of the pipeline corridor. And the surveyor must incorporate that in the navigation software. Now on a survey software, the touchdown point will be a single point on a straight line from the barge stern. So when the barge heading moves a tiny bit, the touchdown point further away from the barge moves a lot. Don't worry, that's not the case actually on the ground. But too much heading changes can really buckle the pipeline. So the surveyors must always talk to the anchor operators to maintain the correct heading. Laying pipe on a carved route is difficult. Surveyor must prepare the barge track, which will be outside of the curve of the main laying track. Barge must be on the barge track so that the touchdown point falls on the actual planned route. Barge track distance from the main route depends on the touchdown horizontal distance. So you must get an approved touchdown distance copy from the field engineer. Nowadays all the pipelay barges uses ROV, which is very useful to know the actual touchdown point, and you can compare it with the theoretical touchdown point and correct it if necessary. Now laying down of the pipe is a complex operation and needs a little bit of calculations. In most cases, you will be laying down the pipe near a platform. So you actually need to veer off from the intended line and lay the pipeline on the side of the platform. Isn't it obvious, right? You cannot actually move over the platform to lay your pipe. So how it is done? First you need to talk to the field engineer and the barge superintendent and decide on the veer off point from where your barge needs to veer off towards the side of the platform. Normally it is between 300 to 400 meters from the end of the pipeline route. Then you need to draw a guideline from the veer off point to the target box where you will be laying down the pipelay head. Navigate on that guideline and keep calculating the distances to go and how many joints to go. Here you need one more data from the field engineer, and that is gain or flop forward. See, the end of the pipeline is on the barge, which is say about 80 meters above the seabed. So when it falls down, it gains few meters than the position when calculated at the beach stall. You can do a simple Pythagoras calculation, but that won't be that accurate as you don't have the information about the catenary or how much the pipeline is sagging. Though the field engineer is supposed to give you the flow forward or the gain, it's always better that you do your own calculations. Remember, all your position calculations are done at the beach stall. So when there is 100 meters to go, you need to deduct the gain amount from the 100 meter and then divide it with the length of the section of the pipe, and that should give you the joints more to go. You also need to discuss one very important thing with the field engineer and ask him whether they want the last joint on the target point or they want the lay down head on the target point. Now the lay down head can be anywhere between 2 to 12 meters, and that you need to take into account when calculating. A strong wire rope will be connected to the lay down head and it will continue laying the pipeline past the platform. As soon as the lay down head is clear of the stinger, the barge will start pulling on the recovery rope and start moving closer to the platform and try to pull the pipeline as close to the platform as possible. Now that may not be the case all the time. Some other barge may come and then recover the pulling head and put it into the position while installing the riser. But this is also an option that you need to remember. And by this time the ROV will already be in the water and barge will start moving back, reeling in on the recovery wire and coming close to the lay down head as possible. When the recovery wire is straight up and down from the barge stinger, the ROV will be coming in there and taking a fix. You also need to take a position fix of the stinger tip and compare the ROV fix and the stinger tip fix together. Once given the signal, the ROV will then cut the recovery wire. And that's done for this pipelay operation. Lastly, I am going to discuss about the reports and the documents the surveyor needs to maintain. And these reports and documents are needed to be produced exactly at the time it is required and not at the end of the pipelay. When the barge sets up anchor before the start of the pipelay, the surveyors must prepare a geodesy report and a lay route approved for construction lay route report and get it signed by the client. You have to make sure that there is no other separate versions of the AFC other than the one that you already have in your nav computer. You also need to have a chart showing all the significant sonar contacts and obstructions, and you need to make all those sonar contacts plotted on your navigational computer with a warning range ring around them. After the initiation, the barge will start pulling ahead. But you will take fix only when the pipeline starts moving from the beach stall. If the barge moves ahead and the pipeline does not move from the beach stall, it means that the barge is taking on the slacks of the recovery wire, and you do not take position fix during this time. Once you have taken the first 8 to 10 position fix, that means the 18th or the 20th joint is already on the beach stall and some 8 to 10 joints are out of the stinger, you can now back calculate the lay down head or the pulling head position. Take the position of the beach stall, calculate the length of the pipe already laid after the beach stall and add the length of the pulling head. The position of the pulling head will be directly behind the barge stern. Make a report and get it signed by the client. After about 35 to 40 joints, the pipeline now can be touching down on the ground. Now this time the ROV will be launched to look at the pipeline profile, and the field engineer can correct the proper depth of the stinger to maintain the pipeline profile. If the pipeline has been initiated using DMA, the laydown head or the pulling head will be on the ground and ROV can take a fix easily. But if the initiation is done via the bowstring, then it will be very difficult. As the pipeline is hanging via a wire, it will be under tremendous tension and it will vibrate a lot, and the ROV will normally stay clear of that pulling head. Even if the ROV is able to go near that pulling head, you need to know the exact height of the ROV from the seabed, as well as you need to know the exact position of the pipeline touching down on the ground. And then only you will be able to correctly calculate the gain when the recovery rope is cut and the pipeline is on the seabed. Now there are many reasons this calculation can go wrong. So it is always better to calculate the initiation head when the pipeline is under tension and about 20 joints have already been laid. You need to maintain the position fixes of every joint when they are in the bait stall. Set up your system in such a way that with one click you can record the position of the bait stall, the stinger hinge, the stinger tip, as well as the touchdown point. Make sure you also record the barge heading at the time of the fix and the cross track error of the touchdown point, as well as the bait stall and stinger hinge. Keep a separate note along the theoretical touchdown, as when the ROV goes and takes an actual fix of the touchdown, you can compare those touchdown points together and make a correction if required. These fixes are called pipe tally, and they need to be given to the client at the end of the pipeline. If the pipeline is crossing over another pipeline, then the crossing fixes needs to be taken. And it can be with respect to the theoretical touchdown, or if the ROV goes down and takes an actual fix of the crossing. These crossing fixes are to be made into one single report and given to the client at the end of the pipeline. Sometimes a barge can also install a subsea valve between the joints of the pipeline. Lastly, you need to make a laydown head position report and make sure that you include the deviation of the pipeline from the actual route. Ideally, the laydown head position should be taken by the ROV and it must be reported and signed by the client. Now, while laying pipeline, the barge actually crawls on the anchor. So there will be a lot of anchor handling and lot of anchor repositioning. For ideal circumstances, only the initiation anchor pattern and the laydown anchor pattern will be approved. But most of the time, it is not possible to maintain the approved anchor patterns. Don't sweat it. Just log all the anchor drop and recovery position and make a report if client wants it. So that is how most of the shallow water pipelay is done. Now I have not discussed about a shore pool or a beach pool here. Let me give you a short brief. When a pipeline end has to come to the shore, a very strong wire rope is connected to the pulling head and taken to the shore and connected onto a winch. Most of the time the shallow segments of the pipeline route is trenched. The pipeline is joined at the bait stall of the barge and is pulled from the shore by the winch, joint by joint. Most of the times when the pipeline comes out of the stinger, some heavy duty floating devices are added to the pipeline so that the pipe does not drag on the seabed. And surveyors may need to go out in a small boat and take the fixes of the pipeline just to see that it is on the route and exactly on top of the trench. You may need to take a periodic position report when you are taking the position fixes of the shore pull, but when the barge actually starts moving ahead, crawling on the anchor, you resume to your normal pipelay position. I hope I have discussed everything and not left anything in this video. There are a few things which I have intentionally omitted and have not shown you due to company copyright policies. Do let me know if you have any questions. I'll try to answer them as much as I can. I'll be around if you ask for me. I'll see you later.